Welcome to our SAT daily lesson. Lately, we've been focusing on math, and this, our first week of this lesson, we are definitely going to be turning our attention over to verbal very soon, and we're really excited about all the great tips that we plan to share with you. Do us a favor and share information about this podcast with all your friends. We're living in a time where a lot of people could use a lot of this information about the SAT. The test is a content-based test. It's not about how smart you are, it's about how familiar you are. And we're here to give you that familiarity. Aspire Test Prep does offer one-on-one online tutoring. We tutor students anywhere around the world. So feel free to go to our website, aspiretestprep.com, or our profiles on any of the social media platforms, almost any, to go ahead and find out more about our tutoring. We've had some amazing success stories, such as a student who in 7 hours went from 1100 to 1400 on the SAT. At this moment, our average student goes up by 11 SAT points per hour tutored and by a third of an ACT point per hour tutored. And of course, that's the average. So we're going to have some students who don't quite hit those exact numbers and some students who blow those numbers out of the water. We'd love for you to be one of those students. So let's go ahead and just quickly recap what we've been working on this week. We've been going through all the different types of factoring that you need to know on the SAT. So we started with BC factoring. If something has x squared in it, and it may or may not have y in it, it's a quadratic. And so quadratics are different than other types of things in algebra because normally you're solving for x. And in a quadratic you are as well, but first you're getting one side equal to 0. So we're just going quickly through notes from things we've done in previous podcasts. So wherever you're contacting us, wherever you're seeing this broadcast through, whether it's in real time or later, you can look through previous versions and you'll see these explained out in more detail, where we found a quadratic, we set it equal to 0, we looked for two numbers that add to b, add to -2, and multiply to c, multiply to -8, and that's how we factor and get our answers. So we went through BC factoring. We also did the same idea when you have a greatest common factor. So here, every term is divisible by 3. And then from there, you can do your BC factoring. This would factor to x plus 4, x plus 5, and x would equal -4 and -5. Like I said, look at previous lessons if you want a more in-depth explanation of that. So more of the same here. Then we said, well, if factoring doesn't work, we can go into the quadratic formula, which is what we have right here. So if you can't find two numbers in this situation that add to 8 and multiply to 2, then you can use the quadratic formula or completing the square. They're both equally useful. They both have different sort of attributes that make them more useful in slightly different situations. But an answer from the quadratic formula can end up looking something like this blue thing right here. A little complicated looking, but it is the answer. It says that x is what you get when you do -4 plus the square root of 14 over 2, or -4 minus the square root of 14 over 2. Clearly, that would be a decimal right there. So this next one is another one that, we could say, okay, well, it's not factorable. It does have a GCF though. So a greatest common factor, you divide out 7 from each term and it gives you that blue expression. Then A is 1, B is -10, C is -9, and you can use the quadratic formula. So going on here to this example that we already did, we talked about how an intersection of two functions is best served by getting both functions in the y equals format. So the first thing we did for this one was we took this expression here and solved it for y, which is what you have right there. So we had y equals x minus 4 over 2, and we were also given y equals 2x squared plus 8x plus 5, and we set those equal to each other right around here. And we went through the solving steps because the answer of this, the thing that you get when you set the both things equal to each other, that answer is itself a quadratic. So we have to go ahead and do the step-by-step process of getting 0 on one side. And once you do that, now you have your A, your B, and your C. So you could solve this using the quadratic formula. But what we were talking about yesterday with Ronan, our student who joined us, is that if you're asked how many solutions, then basically for a quadratic, That's code for, we don't want to find the actual solution. We want to find the number of solutions, and the discriminant, which is this right here, tells you that. So based only on what you get for the b squared minus 4ac portion of it, you'll get, if the b squared minus 4ac, the discriminant is positive, you have 2 answers. If it's 0, you have 1 answer. If it's negative, you have 0 answers. So just by arranging A, B, and C. So for this problem, A is 4, B is 15, C is 14. Just by arranging that into the format of b squared minus 4ac, like we're doing here, and then finding out that that's actually positive. Now we'd be tempted to say 1 answer here because the answer was 1, but it's positive. So that means that there are 2 solutions here. So just kind of quickly recapping things that we've been doing throughout the week, if you've been with us. Here we have another question, another intersection, and another use of the discriminant. And when we solved it up to here, it turns out that it's a smaller number minus a bigger number. So without actually solving it, we know it's negative. So like we were saying yesterday, the SAT is not just set up to kind of fool you and make you get the questions wrong, but also to make you put in more work than you have to put in. So here, I know this is negative. I don't have to actually find what that number is. As long as the discriminant is negative, there are 0 solutions. So going into this one here, now we're sampling the completing the square method, which depends on having b over 2, and b over 2 squared. So in this quadratic here, the b is the 6. So we have 6 over 2, which is 3, and then 3 squared. And you need to know when you do the completing the square method that the b over 2 is what it'll factor to in the end, and b over 2 squared is what you add to both sides. So we added 9 to both sides, and we factored it to x plus 3 squared, took the square root of both sides to get x by itself. So here we practice the completing the square method again. So we already had this arranged in a nice format, but there was a GCF, a greatest common factor of 5. So right here, we divided everything by 5. When you do the completing the square method, you want the x's by themselves. So we subtracted 1 from both sides to get it looking like this. Now in our ax squared plus bx plus c of a quadratic, the b was the negative 14. So we took that off to the side. b over 2 squared. So b was negative 14, b over 2, negative 7, square that, 49. So we're adding 49 to both sides, and it's going to factor to x minus 7 squared, which is exactly what we did. We added 49 to both sides. It factored to x minus 7 squared, and we took the square root of both sides to get an answer for x. So the next big thing we were looking at, and this is all in previous lessons, is 2-term quadratics. So if you have a quadratic and it's got the x squared term and the x term, that's going to require a greatest common factor again. So the greatest common factor seems to be the theme of this review. So in this situation, 15x squared and 35x have a common factor of 5x. Factored that out, it left us with 3x plus 7. The 0 product rule right here says that if 2 things multiply out to 0, then you're able to set both of them equal to 0. So 5x equals 0, 3x plus 7 equals 0, and we get our 2 answers. So like I said, if you have a 2-term quadratic, you're using the GCF to solve that, the greatest common factor. So a ton of things, situations that when you're in that situation, if you remember what to do, then you're better off than your competitors on the SAT. So this was an example where we kind of coincidentally didn't find the greatest common factor because the greatest common factor was 16x for this set of numbers, but we found a common factor of 8x. And we were sort of proving that it still works. So if we factor out 8x, it leaves us with 2x minus 6. Set 8x equal to 0, 2x minus 6 equal to 0, and you get 0 and 3 as your answers. If we did the greatest factor, so more of the textbook way to do this, you'll get 0 and 3. So it's the same answer both times. So now we're moving on to fresh new material, and we're talking about the factor by grouping method here, which is this right here. So the idea here is when you see 4 terms, you have to know that factor by grouping is perhaps the best method. Every situation is different, but you definitely want to be keeping your eyes out once you have 4 terms. So factor by grouping involves a GCF for this, a greatest common factor, for the first 2 terms, and a greatest common factor for the second 2 terms. So when I look at xy squared and negative 7xy, they both have a factor of x, and they both have a factor of y to the first. One of them has y to the second, the other one has y to the first. So what do they both have? They both have y to the first. So I'm going to take out x, y, and when I factor that out, it's going to leave me with y minus 7. Now, for people who are not good with factoring out the GCF yet, what is it that we actually did? We put an xy on the outside, and we took each of the original terms. This is something that if you know how to use the GCF, then you would never even think about this because you just do it automatically in your head. But if I multiply by xy on the outside and divide by xy on the inside, those are two opposite operations. So they're canceling each other. It's like I'm not doing anything. But when we simplify what's inside, xy squared over xy is just y, and 7xy over xy is 7, or negative 7. So that's kind of the mechanics of how you factor by GCF. And leave us comments, let us know how it's going. If anything we talk about is something that you're going to need a little extra help on, we definitely would love to hear that, and we would love to give you help on any area that you express that's important to you. So now we're taking the GCF of these two terms, the greatest common factor of negative 4y and 28. So both of those are divisible by 4 or negative 4. So let's say negative 4, and we'll talk about the negative sign in a second. But if you divide that out, it leaves you with y minus 7. Okay, when you're doing the factor by grouping method, you need this. This is a big checkpoint right here where you look and see how things went, and these two things need to match. So it's not the right color for that. So y minus 7 and y minus 7, they match. So if we were doing this at this checkpoint, we'd say, okay, we're doing it right, and we can move on to the next step. But if we had factored out positive 4, which is totally logical as well, plus 4 right here, well, that means that I would need negative y to distribute back out to negative 4y, and I would need positive 28 to factor back out, right? So here we have these two things not matching. Actually, positive 7, sort of doing too many things at once. But we have y minus 7 and negative y plus 7, so they don't match. So that's why out of our choices here, we have choices to make. We want to factor out negative 4, and that would give us what we need. So now we can think of this as two terms, term number 1, term number 2. They both have a factor of y minus 7 to them. So if I factor out y minus 7, it leaves me with xy minus 4. So to recap for the factor by grouping method, this is something that you want to know how to do when you see 4 terms there. And the main idea of the factor by grouping method is to factor the first 2 terms, factor the second 2 terms, and then take a GCF from the results of doing all that. So moving to the next example here. So we have 1, 2, 3, 4 terms. So that's supposed to remind us to possibly use the factor by grouping method here. So when we give it a try, we have the first 2 terms. They have a common factor of CD. Both of them have at least one C and at least one D. So if I take out CD, C squared D divided by CD is C, and 3CD divided by CD is 3. Then I'm going to factor out negative 2, because they both have a factor of either plus or minus 2, but we'll know that we did it right when we go ahead and see that the 2 items in parentheses match each other. So if I factor out negative 2, I have positive C here and positive 3 here. So the way we did it was correct because these 2 things match. So we'll factor out C plus 3 from this term and this term. They both have C plus 3 in them. So when you factor that out, what does it leave you with? CD minus 2. CD minus 2. And so we've officially taken this and factored it. Now, if you're a beginner at factoring, you want to be an expert at foiling, because you don't need the question to tell you if you got it right. You can just FOIL it back out. So first times first is C squared D. Outer times outer is negative 2C. Inner times inner is 3CD. And last times last is -6. So c squared d minus 2c plus 3cd minus 6. The order is a little different, but it is indeed equivalent. So moving on. Now we're moving on to ABC factoring. So before we were talking about BC factoring. BC factoring, which we did a lot of earlier this week, would be if I saw a number here and here, but no number here, then I have something, I have nothing in the A spot, but I have something in the B spot and something in the C spot. So if you're doing BC factoring, you're looking for two numbers that add to B and multiply to C. Now, that would be in a situation like this: y equals x squared plus 7x plus 10. So you've got numbers here and here, but you've got nothing here. You've got the invisible number 1, right? But if we have a number besides the invisible number 1 in the A spot, now we're doing ABC factoring, and that's what we're talking about right now. As opposed to needing two numbers that add to B and multiply to C, now we need two numbers that add to B and multiply to A times C. So in our situation, they need to add to 11, that's our B, and they need to multiply to A times C, 6 times -10, -60. So what are the two numbers that add to 11 and multiply to -60? If you get a sort of a tougher situation where the numbers are a little tougher to figure out, what you want to do is you want to go systematically. There are infinite numbers that add to 11. For instance, 1,011 minus 1,000,000 would equal 11. So if we start by looking for the numbers that add up to what we want, we're usually going to have a tougher time. But there are a limited number of integers that multiply out to 60. So divide 60 by every integer going in order. So 60 divided by 1 would look like this. 60 times 1 is 60. 60 divided by 2. 60 divided by 3. And I know we're not going to need some of these, but it just feels good to kind of go in order to have everything nicely under control. So now we have the 15 and times 4. And we're going to go ahead and say, well, 15 times 4, that's actually 60. And 15 minus 4 is 11. So those are our numbers right there, +15 and -4. So the next thing you do is you take the middle term. So we started with, one second here. We started with 6x squared plus 11x minus 10. And we're going to go ahead and split the middle term into 15 and 4. So 11x is going to become 15x minus 4x. And we're still going to have the 6x squared that we started with and the -10. So far, we haven't changed anything, but we've changed the appearance. We took the 11x that we started with and we split it into 15x minus 4x. So we haven't broken any rules of math, and it's really important to notice that. So now, why did we talk about factoring by grouping a moment ago? Because that's what we can do at this stage. When you're doing ABC factoring, once you split up the middle term, according to these rules that we gave you a moment ago, now you can do GCF factoring. You can do factor by grouping because you have 4 terms. So 6x and 15x both have a factor of 3 and x. And if I factor out 3x from those two, it leaves me with 2x plus 5. -4x and -10, they both have a factor of 2 or -2. So let's take out the -2. If we had tried +2, we would notice that the parentheses don't match and we'd have to start over, but we're just kind of going through a little fast here. And you have to have 2x plus 5 again. So like I said earlier, at this stage, these two guys must match, and they do indeed match. So we get a little screen flickering here thanks to Microsoft OneNote, which never ceases to come out with new glitches to challenge us in our SAT journeys. Thanks, Microsoft. But we're going to go ahead and factor out 2x plus 5. 2x plus 5. And it leaves us with 3x minus 2. And we're done. So ABC factoring can be a little tricky. It requires a little repetition. One place I go to as a tutor is Kuta software, Kuta. And if you go on Google and look for Kuta or type in Kuta, Kuta, and search for polynomial factoring or trinomial factoring, you'll get a nice worksheet with the answers and everything. That'll help you to get enough practice on a subject like this. So let's try another one of these now. So we've got 6x squared minus 5x, okay. 6x squared minus 5x minus 21. So to start this out, it's ABC factoring because we've got terms in the A, B, and C spots. So we're looking for two numbers that add to B and multiply to AC. So they need to add to -5 and they need to multiply to whatever you get for 6 times 21. So 6 times 21 is 126. So actually, since I can only write in highlighter because of my Microsoft glitch, thank you, Microsoft, I'm going to go ahead and switch to another screen. And use this other Microsoft app, which doesn't have the glitch. So we were looking for two numbers. Ah, it's the same glitch. Okay. Well, I've learned my lesson there. Okay, so coming back over. So two numbers that add to -5 and multiply to 126. So what are the numbers that do that? Let's just kind of go ahead and divide 126 by every number that we can. So 126 times 1. 63 times 2. Does 126 divide by 3? Yes, it's 42 times 3. And we're looking for combinations of these numbers that can add up to 5. So divided by 4. And it doesn't divide by 4. It doesn't divide by 5 either. By 6. And you get 21 times 6. Now 21 minus 6 is 15, so we're getting closer, right? 126 divided by 7. Okay, so it's 7 times 18. Feel like we're getting warmer here. 126 divided by 8. It doesn't divide evenly. Divided by 9. So 14 times 9. 14 minus 9 is 5. 9 minus 14 is -5, so we found it. So we're going to take the -5x and we're going to split it up into -14x plus 9x. Could I have split it into 9x minus 14x? Absolutely, it still would have worked. So you have 6x squared minus 14x plus 9x minus 21. And so we've just basically taken this middle term and divided it into two things that are equal to it. But we haven't actually changed anything super important. But we can go ahead and factor the first two terms and the next two. So the first two terms are divisible by 2x, which leaves us 3x minus 7. And the next two are divisible by 3, which leaves us, what do you know? 3x minus 7. So now we have these two terms, this one, and they both have a factor of 3x minus 7. So we can factor out 3x minus 7. And that leaves us with 2x plus 3. So by the way, because this is all equal to 0, even though we weren't including that up to this point, because this is equal to 0, that means that the zero product rule says that you can set both of these equal to 0 now. So 3x minus 7 equals 0, 2x plus 3 equals 0. And you can solve both. So add 7 and divide by 3, and you'd get 7 over 3 here. Take away 3 and divide by 2, and you'd have x is -3 over 2. So the two answers to satisfy this, the two roots of this quadratic are x equals 7 over 3 and x equals -3 over 2. So now we're moving on to something totally different. We are absolutely required on the SAT when we see a situation like this to know that it's a difference of squares. So what's a difference of squares? It's got a perfect square, so it's got the squares, and then a minus sign in between, the difference. So literally a difference of squares. You're supposed to know that something like this will factor to the square root of each piece with a plus and a minus in between. So 2x plus 5, 2x minus 5. How do we know that? Just from having gone through a lot of these in the past. If I FOIL this out, first times first, outer times outer, so negative 10x, inner times inner plus 10x, last times last, negative 25. This is what will always happen, negative 10x plus 10x, and this will cancel away. So if I have two terms that had kind of the same two binomials multiplied together that have the same terms with a plus and a minus in between, so 2x plus 5, 2x minus 5, a plus b, a minus b, that kind of thing, you're supposed to kind of know by heart that if you were to FOIL that out, the outer and inner terms of the FOIL cancel each other. And so you'll end up with two terms. So in this case, 4x squared minus 25. So what does that tell us? The opposite. If I see 4x squared minus 25, a difference of two perfect squares, I can easily factor it to 2x plus 5, 2x minus 5. Here's another example. 36w squared, 81z squared. So is this a perfect square? Yeah, because the square root is 6w. Is this a perfect square? Yes, because the square root is 9z. So you can factor it to expressions with a plus and a minus, and on either side, the square root of each piece. 6w plus 9z, 6w minus 9z. And that should have been a 6. And so if you were to FOIL this out, you would get 36w squared minus 81z squared. And in the O and I of the FOIL, those two things would cancel each other out, leaving you with just the two terms that we need. So that would be how we would check something like that. So last but not least for today, we're talking about perfect square trinomials. So it's one of our last sort of factoring categories that you need to know in order to excel on the SAT. So before we were talking about a situation where we would have, let's say, a plus b and a minus b, and you're going to get that cancellation in the outer and inner terms. But if I had a plus b times a plus b, the outer and inner terms are not going to cancel out. In fact, they're going to double up. So let me sort of show you what that means. If I were to FOIL this out, I'd have first times first, outer times outer, inner times inner, last times last. So what's happening? The AB and the AB are doubling up on each other. It's going to look like a squared plus 2ab plus b squared. Now, that is a perfect square trinomial. Perfect square meaning that the factors are the same as each other. So why is 25 a perfect square? Because the factors are 5 and 5. Why is a squared minus plus 2ab plus b squared a perfect square? Why is it a perfect square? Because the factors are a plus b and a plus b. So every perfect square trinomial has certain attributes to it, and that's what we have up on the screen here. When you have a perfect square trinomial, the first term will be a perfect square, which in this case, x squared, the square root is x. The third term is a perfect square. So what's the square root of 4y squared? It's 2y. This actually should be a plus sign here. That one snuck by us there. But the middle term should be equal to 2 times the square root of the first term and the square root of the third term. So right here, we're just gonna retype this. The square root of the first term and the square root of the third term. Okay, so just kind of going through what that means. So the first term is a perfect square. Is x squared a perfect square? Yes, because the square root is x. Is 4y squared a perfect square? Yes, because the square root is 2y. The middle term, negative 4xy, it needs to be equal to 2 times each of those things. And is it 2 times x times 2y? Is it equal to 4xy? Yes, it is. Now we're purposely ignoring the signs. I'm going to tell you about that in a second. But as long as these three things are met, which they are, it's going to factor to this and this. So this is going to be x and 2y all squared. It's a perfect square. But because we had a minus sign right here, it's going to give us a minus sign right here. So the perfect square trinomial test, you test it out, and as you're doing that, you're factoring it. So x squared minus 4xy plus 4y squared is equal to x minus 2y times x minus 2y, better known as x minus 2y all squared. So let's go through one more of those. Right here, we've got 36a squared plus 72ab plus 36b squared. Okay, so is the first term a perfect square? Yes, it is, because the square root of 36a squared is 6a. Is the third term a perfect square? Yes, it is, because the square root of 36b squared is 6b. Now, the middle term, according to this perfect square test that we're learning right now, has to be equal to 2 times each of those things we just found. So 6 times 6 is 36, times 2 is 72, AB. So this is 72AB. And so now we've got all three criteria of the perfect square test being met. So it'll factor to 6A and 6B all squared. And the last thing we need is just to check what's the sign for that middle term, and that'll determine the sign that goes in between, which in this case is plus. So the only way to really confirm whether this works is to go ahead and FOIL it back out. So 6A plus 6B times 6A plus 6B, first times first. So we have this times this, 6A times 6A is 36A squared. Outer times outer, 6A times 6B should be 36AB. So plus 36AB. Inner times inner, 6B and 6A, that's another 36AB. So the outer and inner terms are doubling up. They're going to combine to give you 72AB. And that's exactly what we started with, so that's great. And last times last is 6B times 6B, so 36B squared. So when we took our answer, we took our answer, which was 6A plus 6B all squared, and we went ahead and multiplied it back out, and it gave us exactly what we started with. 36A squared plus 72AB plus 36B squared. So factoring it as a perfect square worked out. So we're really excited about what we're doing. We attempted to do this lesson in real time earlier this week, but we're just figuring out the technicalities, the surprisingly complex technicalities of broadcasting in real time, going live, so to speak. We're really happy that it's finally working out, but we're depending on your feedback to let us know what you want to see more of. And we're also depending on your help letting people at your school know that during school hours, we have a free SAT lesson being done every week, 5 days out of the week. So go ahead and spread the word, do us that favor. And if there's anyone who's in a crunch needing SAT tutoring and the tests are coming up and things haven't been working out, come to us. We're some of the most specialized SAT tutors that you'll find anywhere in the world. So thanks so much for joining our broadcast and have a wonderful day.